So, good day. Welcome to the final unit, the final lesson in our unit on trigonometry, study of triangles, trigonometry overview. What I'm going to do is walk you through the concepts of this unit and then assign the final review after that. So let's start with a couple of triangles. And we want to solve each of these triangles for their unknown angles. Let's start over here. We want to solve for this angle. We have two known sides. We have the 2 and the 8. The 2 is opposite. The 8 is adjacent. We don't know the hypotenuse. So in this case, to find this unknown angle, tan inverse 2/8. And to refresh you on that procedure, second tan, that's tan inverse 2 divided by 8, gives us a 14-degree angle down on the corner. And we can solve for the other missing angle with relative ease. Now that we know that one, we know the other one is a 90, 180 minus 90 minus 14. (76). So there's a couple of concept reviews. Tangent and subtracting from 180 degrees. Let's have a look at this one. We have an unknown angle here. Again, we have 4 opposite, 6 adjacent. So again, this is a tangent example. Tangent inverse 4/6. I don't think I need to demonstrate again. Second tangent 4 divided by 6. 33.69. I'm going to round that off up to 34. Solve for the other missing triangle. Very easy work. 180 minus 90 minus 34 is 56. So using tangent to find unknown angles was one concept. Let's have a look at another concept. Sketch a couple more triangles here. I have a 61-degree angle up here. We're going to have a right angle, and we're going to have the short side here of 6. And let's do another triangle. Might as well sketch them both and then work our way through. Right triangle with this time a 27-degree angle down on the tip, and a right angle, and the short side on this one 5. So what we want to do here is use tangent to solve for unknown sides. So I'm going to solve for this one, this one. If I want to solve for this angle here, that's easy enough as well. Subtract the other two from 180. Same with this one. But this will do the way it is for our purposes of finding two unknown sides. So here's our known angle. Here's our unknown side. And here's our known side. So if we look at where the angle is, this side is opposite, this side is adjacent. This becomes, again, tangent of 61 equals x over 6. So when it's set up, when it's laid out like this, you do tangent 61 times 6, and therefore x will be equal to calculator. You don't need inverse this time because it's not an angle. Tan 61 times 6, 10.8. And I'm going to just finish the job here. Find the hypotenuse, the long side. A squared plus b squared equals c squared. Right? So we have A, which is 6. We have B, which is 10.8. We're trying to find C. 6 squared is 36. 10.8 squared. 10.8 times 10.8 is 116.64. $152.64. 12.35. 12.3 is our hypotenuse. Right, that's that one. Using a combination of tangent and Pythagoras. Let's move to this one here. I'm going to begin by solving for this unknown side right here. This time we know the opposite side, and the unknown side is adjacent to the angle that we're working with. Tangent 27 degrees equals 5 over x, because this time the known side is opposite. So what do you do when this happens? Tan 5 divide by the tangent of 27. And let's just show you that. 5 goes in first. That does make a difference. That's how you always do it. Tangent 27. 9.8. And the hypotenuse once again presents itself as unsolved. A squared plus b squared equals c squared. 5 squared at 9.8 squared equals c squared. 25 at 9.8 times, 9.8 squared is 96.04. So this will become 106, 116, 121, 121.04. And I don't think I'm going to be finding that square root mentally. Without the decimal, that would be 11. Second square root, 101.21. It's almost 11. It's like 11.001. We'll call it 11. It's close enough. X equals 11. That's an overview of tangent with a little bit of Pythagoras blended in. Now let's move on to another concept of the unit. We'll be looking at this time solving triangles using some of the other ratios that we did. So let's try this one, for instance. So this triangle, it's a right triangle. It has a 33-degree angle down here, and it has a short side of 12.5. And we're being asked to solve this. first, I'm going to get this angle up here. So 180 minus 90 minus 33. 57. Degrees. Now then, we have a known side here of 12.5. Let's begin by solving for the hypotenuse, the long side, x hypotenuse. And I'll do the work right here. So we have our known side there, 33 degree. Let's use the 33 degree angle. The known side is opposite of it. And what we're trying to find is the hypotenuse. So we're using the sine ratio, which is opposite over hypotenuse. So sine 33 equals 12.5 over x. So when it's like this, .5 divide by sine 33. 22.9. Now, the other unknown side here is this one. And let's just stay with the 33 degree angle. So we have a couple of known sides now. Let's use the hypotenuse this time. Okay. So the side we're trying to find is right beside the 33 degree angle, so it's adjacent. And our hypotenuse that we just found is 22.9. So it's adjacent over hypotenuse, that becomes cosine. So cosine 33 equals x over 22.9. This time you can see clearly your x is on top. Cosine 33 times 22.9. $19.2. A triangle solved. Let's do another one like that, shall we? This one, it's got a 5.9. It's got a 47 degree angle up at the tip. Let's do the easy thing first. Solve for the unknown angle. 180 minus 47 minus 90. $43. Now then, let's solve this middle side, this unknown middle side first. And let's use the 47 degree angle up top here. We could use the 43, doesn't matter. But from the 47-degree angle, the unknown angle is opposite, and the 5.9, the known angle, is adjacent, right beside. So opposite over adjacent. Tangent of 47 equals x over 5.9. Of course, I'm multiplying 6.32, so 6.3 is the unknown side, and we have a squared plus b squared equals c squared. 5.9 is a, oh sorry, I'm solving for that hypotenuse, of course, for this one. I'm just jumping ahead here, getting ahead of myself. And I'm using a squared plus b squared equals c squared. So 5.9 is the short side. 6.3 c squared. .81 and 39.69. $74.5. Square root of that. Is 8.6. So we have our hypotenuse of 8.6. I think we should do one more example here. Yeah, there's one. We have this triangle. It's got two known sides. It's got a 9.8 and 5.6, and it's got a 90-degree angle. So we're dealing with two unknown angles here. So we're going to have to use trig to find one of them. Let's try finding this one up top. So you look at where your known sides are. You don't have the hypotenuse, so automatically you know you have to use tangent. So 9.8 is opposite, 5.6 is adjacent. So tan inverse 9.8 over 5.6. $60.25 or 60.3. We're going to call it a nice even 60 degrees. Right, round it off a bit. 180 minus 90 minus 60 to find the other angle there. $30. And that leaves us to solve for the hypotenuse. Now, we could use Pythagoras, we could use trig. Let's use tangent. Let's use trig with the 30-degree angle here, right? So we've got 5.6 is opposite. Let's go with that. 5.6 is our known side. It's opposite of the angle we're going to use, and x is the hypotenuse. So we're going to be using sine, opposite over hypotenuse. Again, could have used Pythagoras, but just for some extra practice here, sine of 30 degrees equals 5.6 over x. Therefore, we're going to have 5.6 divided by sine of 30 degrees. 11.2. A lot of times it's just a matter of preference. What do you prefer? What are you comfortable with in terms of solving for an unknown side? Like here we could have used, we used sine. We could have used cosine. We could have used this side, 9.8, and we would have been using cosine. So it would have been cosine 30 degrees, 9.8 over x. Or a squared plus 5.6 squared at 9.8 squared equals c squared. You get a whole bunch of options for doing this particular question, and really most other questions as well. So, continuing with our walkthrough of this unit, the overview of the unit, basically taking you through most of what we covered. So, let me dig out a couple more questions here. Take Hello.
Sorry, visst var det?
I'm doing a recording, otherwise okay. Du vas kolla drauf sein.
Jag kollar på hur man står och se Artem Shamiv's anschaftet.
Okay.
Sekretärin ist Islands aufzutreten und alles exakt. Was ist das konstigt?
Ila gaho kommer. Så va.
Hast du Pausen?
Oh, ich komme.
Ja.
Okay, to continue on, just setting up another sketch here. This side is 5. Got a 20-degree angle here, a 40-degree angle here. You of course have a couple of 90s down there. So, you want to solve here for all unknown sides and unknown angles. So, 90, 20, unknown. Let's solve for this one. 180 minus 90 minus 20 is 70, and then 180 minus 90 minus 40 is 50. So we now have all of our angles. They share a side here. So we're looking to solve then this side, this side, this side, this side for each triangle. And we should be able to do that because of the common side here. So let's begin with this triangle with its short side. So we have a known angle and a known side. So 70 degrees, this known side is opposite and the unknown side is adjacent. So we're using tangent. We're using opposite over adjacent. Tangent of 70 degrees equals 5 over x. You can very quickly see this becomes a dividing question. 5 divided by 10, 70. 1.8 is the length of our side, which makes sense. If this one is 5, and this is the short side, so it's a little less than 2, 1.8. And we're looking for this side here now. I'm going to use Pythagoras for that one. A squared plus b squared equals c squared. We have an a That's 1.8. We have a b, that's 5. And we have c squared. 3.24 add 25. .3. That's done. This entire triangle is solved. Now for this one. Again, I would start with the short side, right here. So, and again, we have the known side of 5 and the known angle of 50. So let's begin here. Again, we get opposite over adjacent. We're right back with tangent again. This time we have a tangent of 50 and 5 over x. Really, almost the same thing. Tangent of 50 equals 5 over x. 5 divided by the tangent of 50. .19 or 4.2. Our hypotenuse, I'm not going to use Pythagoras this time. Give you some more, a little more trig practice, eh? Use this angle and this side and there. So the known side is opposite and x is the hypotenuse. Opposite over hypotenuse is sine. Sine 50 degrees equals opposite, which is 5. Unknown, x, hypotenuse. We quickly see that we're in a dividing situation. 5 divided by the sine of 50. .5. So there we have our entire triangle now solved. Let's do, well, I think just one more question should suffice, but I'm gonna grab a sheet. There's not enough space on this one. There's our sketch. A 15-degree angle, a 60-degree angle, a couple of 90s as usual. Let's solve for the unknown angles. 180 minus 60 minus 90. Comes 180 minus 150, which is 30. 180 minus 15 minus 90, that becomes 180 minus 105, right? 75. So we have a 30-degree angle down here and a 75-degree angle down here. And they both have a known side of 3, as you can see. We have an x here, an x here, and we're going to solve for both hypotenuses as well. So let's have a look. We have this angle here, 30 degrees. The 3 is opposite, the unknown side is adjacent. Seems we're using tangent again. Tangent of 30 degrees equals 3 over x. 3 divided by a tangent of 30. .1, 5.2. Let's solve for this hypotenuse now. Sine, I'll skip Pythagoras for this example. Let's use all trig. This is opposite, that's the hypotenuse. 3 is opposite, x is the hypotenuse, opposite over hypotenuse. Sine of 30 degrees equals 3 over x. 3 over the sine of 30. Oh, comes out to exactly 6. How do you know about that? Wait a minute, what did I do? Never mind. It's just so rare to get an example in trig that's not a decimal that you just are surprised when it happens. But anyways, moving over here, got our unknown side, the short side again, we have our known angle. This becomes 75. The 3 is opposite, the x is adjacent. Tan 75, 3 over x. 3 divided by the tan of 75. We get the short side of 0.8. Which makes perfect sense. If you've got a 3 here, this side is even shorter than that. Get a 0.8. And now for our x, the hypotenuse. 75-degree angle. We're going to use this one. Well, let's use the 15. He's feeling lonely up there. So the 15. The 3 is beside him. Let's use the 3. That's adjacent, and the x is the hypotenuse. So we're now using, because the 3 is adjacent to the 15-degree angle, we are now using cosine. Cos, 15 degrees, 3 over x. And this simply becomes 3 divided by cos 15. And that becomes 3.1. That's it for our walk through of trigonometry. Combination of sine, cosine, tangent, Pythagoras, and the simple concept that the 3 angles of a triangle add up to 180 degrees. Put those 5 things together, and that's basically what our unit comes down to. So sine equals, let's summarize that, shall we? Opposite over hypotenuse. Cosine, probably the one we used about the least. Adjacent over hypotenuse. Tangent, and of course there are short forms for each of these, tan, sin, and cos. Tangent then becomes opposite over adjacent. And these ratios all depend on where your known angle and known side is located. That's what they depend on, and then you decide which one you're going to use based on that, as you've seen multiple times. And a squared plus b squared equals c squared, that we've been using for a couple of years now. And of course, three angles of any triangle, not just a right triangle, any triangle, equal 180 degrees. Right, now it's going to tell you which questions you're going to be doing for the review and handing them in for marks, of course. This review will not count for the upcoming report cards, but everything else will. Everything that's been assigned in math so far will be used for report cards, except for this assignment. It's the only one that will be exempt. Page 124. 1 and 5, page 125, 11 and 15, and page 126, number 18. And altogether, this will be worth 25 marks. You will find this very similar to the walkthrough. When you're doing the review, once you've done this walkthrough class, if you're smart enough to do the review while that walkthrough class is fresh in your mind and you've done all the other work, should not be having too many difficulties. And with that, let's take a quick look at those exercises. So we have page 124, 1 and 5. We've got a couple of triangles where we're simply solving for an unknown angle when we have two sides. So you'll be using inverse there for number 1. And then we've got a couple of examples down number 5 where you'll be solving for an unknown side. In this case it's K. In this case it's P. Where you have a known angle and a known side and you decide which ratio you're going to use. Feel free to sketch the angle into such a position that it works better for you. Like you could have K, you could set this triangle down on its bottom, so K would be the bottom and the short side going up, and then your hypotenuse. And in fact, I would recommend it. And same thing with this one. P is your bottom. Sketch this triangle so that it's sitting straight and label your sides, label your angle. Away you go. Solve it. So for A, you're supposed to solve for the unknown side, and then you're supposed to use Pythagoras to find the hypotenuse. So you're using trig to find side B, or K and P in this case, and then using our old friend Pythagoras to find the hypotenuse. So make sure you're doing B as well for 5. Over to page 125. Number 11. Determine the measure of each indicated angle to the nearest degree. So they're simply asking you to find an angle where you have two known sides. That's all they're asking you to do, and that's the one that's marked off here, the one that's marked off here. They're not asking you to solve the whole triangle, just one angle. Again, you'll be using inverse to do that, and either sine, cosine, or tangent, depending on what your known sides are. For both of these, you can see it's the hypotenuse is one of the known sides, so that eliminates tangent. It'll be sine or cosine for number 11. Little hint there for you. 15. The last concept of the, or not really, no, not the last concept, but determine the length of each indicated side to the nearest tenth of a centimeter. So here we have, we're trying to find this one here, right? E. So you decide which ratio you're going to use. You have a known side and a known angle. For each one of those, they're giving you a known side and a known angle, and you are to find an unknown side. You're not expected to find the other angle or the other side, just the one unknown side for 15 for each of those. And you'll be using any of the three angles. It all depends. Let's take a look at this very first one here. There's the unknown side, there's the known side. 33, the unknown side is adjacent, and the known side is your long side, your hypotenuse. So that's cosine. That's adjacent over hypotenuse for your first one. So you do cosine 33x over 4.7. And then you would do it. That's 15a. 18. Last question. 18. Now you are solving the entire triangle using any method you would like. So for this one, you get two known sides. I would use Pythagoras to find that hypotenuse. A squared plus b squared equals c squared. Then you're going to have to use inverse to find one of the angles. Either this one or this one, doesn't matter. Once you have that angle, you'll subtract it from 180 together with the 90 to get the other one. That's how you do the first one. So for each of these, you're to solve everything. All three sides and the two angles. Look at this one here. You've got to know an angle, you've got a 90, just subtract. Then you've got your angle, you're going to solve for the sides. And what I would do, I would use trig to find this shorter side here. And then I would use Pythagoras to find the hypotenuse. See? 18c, let's have a look here. Again, a known angle and a 90. Subtract to find this guy up here. And then, your hypotenuse is your known angle. In this particular case, I would use trig to find this side and this side. Either you use the 27-degree angle or whatever the angle is up here. So if you're going to use trig to find this side with the 27, this side is opposite, and 4.4 is your long side, your hypotenuse. That's sine. Sine 27 equals x over 4.4. That's right away, it's a multiplying question. And I would use trig to find this side as well. You could use Pythagoras for this side. You have to remember to subtract because your known side is the long side, side C, then you're subtracting. So if you're going to use Pythagoras for your last side here, you better remember subtract. And finally, of course, 25 marks, as I said, for this final review. That wraps up this unit on trigonometry. I won't make, this has been a long recording, but it's going to be the only one I'm going to make this week. That's going to be it. Everybody needs to get all their work done for trig. This assignment is the only one that will not count for report cards. The rest will need to be in this week. I am writing report cards this week. So you've got till Thursday. Maybe I'll take some on Friday, but that's going to be it. So if you're going to have a decent report card mark and you have outstanding math assignments, they're going to need to come in.